this example, we're going to find a missing side length using Pythagorean theorem in a rectangular prism. So you will see that you have a blue prism, and then inside there is a red right triangle inside. But you actually don't even need a lot of what's here, because if you look at the directions, all we have to do is to find the length of CB. So really, the only thing I'm focusing on in this question is this right triangle that's at the bottom. Whoops. So you'll see here's a leg, here's another leg, and here's the hypotenuse. And you may not be able to tell that this is a right triangle, but the reason I know it's a right triangle is because it's a rectangular prism. So if I took that little right triangle out from the bottom of that prism and just put it flat and laid it flat in front of you, it would look like this. We would have a right angle. We would have this side length that's called CD, that's 3 units. We would have the bottom leg, which is called DB, which is 4 units. And you're trying to find the length of CB, which is the hypotenuse. So all we have to do is figure out C using Pythagorean theorem. So A squared plus B squared equals C squared. This is actually a special example called a Pythagorean triple. I don't want you to have to worry about that, but it does have a special name. All right, so this is going to be called A. We'll call this one B. And we're trying to figure out C. So 3 to the second power is 9. 4 to the second power is 16. And we don't know C, so we'll leave it as just C squared. 9 plus 16 is 25. So C squared equals 25. So in order to find the length of C, I've got to take the square root. And this is a nice one because it's a perfect square. So C equals 5 because the square root of 25 is 5, which means the length of CB is also equal to 5.